Okay, so here we are. We're on section 2.3. Section 2.3. Number 1. So we got to get through this. Both these are actually due. We got to get through this one also. Both these are due on two. This is a 2-section day, unfortunately. Okay, so is it, if you can see that question, is it strictly decreasing on the interval? They say interval. Let me write it. It's off the screen a little bit there. Interval 1, 3. Is it decreasing on the interval 1, 3 is the question. So let's find the interval 1, 3. Now, it's a little tricky. When they write 1, 3, they could actually mean two different things. If they say 0.13, then that's an x and that's a y, right? That'd be like over 1, up 3, be somewhere like there, you know. But they didn't say that. They said interval 1, 3. When they say interval, those are both x values. Do you realize that? So parentheses, comma, two numbers can actually mean two different things depending on the word in the front, point or interval, right? If it's a point, that means over 1, up 3, x, y. But if it's an interval, they mean on the x-axis. Whenever they say interval, they mean both are x values. So they mean from 1 to 3, this chunk of the x-axis. That's what they mean because they said the word interval. They didn't say point. So you got to watch out. The parentheses with the two numbers can mean either thing. So, all right, so interval 1, 3. So they're saying on the interval 1, 3, they mean that part of the graph, which means that part of the graph right there, huh? They're saying, is that part of the graph, is that going up or down? That's a roller coaster. Yeah, well, if you're going that way, you're decreasing, aren't you?
Why would you go that way?
Yeah, which way are we going? Yeah, we're always going to the right? Because otherwise we'd have no way of saying it, right? Because a mountain goes up and down depending on which way you go on it. So you're all in math. We're always talking about as you go to the right. Just want to make sure. So that one's going up. That's an increasing. So is it decreasing? No. On that. Yeah.
So if you were over between like -2 and 0, where it goes up and then down.
Yeah.
It's still increasing, right? Because it starts higher than.
This right here.
No, that's decreasing.
Oh, where are you looking at? Was that the part you're looking at?
Oh, I'm sorry. I can't read things.
Oh, you have -5 here?
I'm just making stuff up. Like, I was like, that -2 right there aligns with that, I'm tired, that point right there. So it goes up and then down. So I'm like, how do you know if it's increasing or decreasing? So don't worry.
All right. You're good. I'm good, Rebecca.
Yeah.
It's all good. All right. Yeah, so just going up or going down, that's all we're looking at. Okay, so this one, they're saying, list the intervals. Again, interval, that'll be parenthesis x with x, huh? Where it's decreasing. Where's the roller coaster going down? From here to here, it's going down in that section, huh? So that'd be from -1 to +1, which is what they said. Good there? That section of the roller coaster. So remember, interval always means x values. From x value -1 to x value +1. The roller coaster's going down. Okay, so how about number 4? They're asking on question number 4, they're saying, is there a local minimum? Is there a local minimum? Now, first off, they mean this point. That's a local minimum. Now, why are they using the word local? Why don't they just say, is there a minimum? Minimum is lowest, right?
Because there's maximum.
Well, there's other.
Oh, wait, the infinite.
There's other lower points, aren't there? Yeah. Right? See this graph here? It goes down, down, down. There's other points that are lower.
The one closest to where you're at.
This point is a minimum in his locality. Just in his little neighborhood, right? In his little neighborhood, he's the lowest in his little neighborhood. He's not the lowest overall. So we don't say he's a minimum, period, because he's not. If you're going into calculus, they'll talk about the difference between a local minimum or maximum. Same thing on this other graph, right? Here would be a local max, right? This is a local max. But that's not the overall max because the graph goes higher later. So they'll talk about the difference between a local max or min and a global or absolute max or min, right? Very, very different. It's kind of like, when you're good in high school sports. Maybe you're like a really good soccer player or football player at your high school. Then you think, man, I'm it. And then you go to the university and you're like, oh, yeah, there's other people that are more it than me, right? I was good in my little neighborhood, my town. I was the hot shot, but, you know, so, right, that's what happens to a lot of athletes when they move out to the bigger stages, right? So you're good in your locality, but not the global, right? So there we go. So that's what they're asking for there. That should be easy. They ask you for the x value, or then they want the y value. The y value is -9, so the y value here is -9. For some old definitions. They're going to... remember how we talked about... Let me just write it here. Remember how we talked about... I'm already writing the new word. Remember how we talked about if a function has y-axis symmetry, be like that one, for example. It's identical on the two sides of the y-axis. And then we also talked about origin symmetry. Here, I'll do a different one. Instead of our sine graph, we'll do that one. So that one has origin symmetry because if you turned it upside down, it would look the same, right? Or all the points reflect like any dot reflected through the origin, same distance, that dot would be on the other side, right? Anyway, so we talked about that. That's not new. Since an hour ago, anyway. Anyway, they're going to give new names to these now. Anybody already know? What's y-axis symmetry called? What's the other name for y-axis symmetry? It's an even function. Where are they getting that word even? What's even? Do you see?
Symmetrical.
What's that graph that's sitting there? What is this graph?
A parabola.
And what's his equation? Y equals x
Squared.
even 2. That's where they're getting that name. Because even power functions do that. So they just said, hey, let's call these even. So that's just another name. Y-axis symmetry is also called even function. Synonymous. Yeah.
If it was like y equals -x squared 2, would that be going?
Yeah, that would be down. So that would also be an even function. Yeah. Now, origin symmetry also has another name. Can you guess it? Yeah, it's odd. It's an odd function. And why do you think it's odd? What is this graph I put here? What's that equation? Y equals, do you recognize that one? It is almost exactly tangent, but it's also x cubed, which is an odd power, hence the name. Yeah, so we're going to go crazy with these graphs just next week. Next week, we'll start doing x squared, x cubed. We'll move them, flip them, do all kinds of crazy stuff. You'll be very comfortable with them. So, x squared is even. So that's just new names for the same thing. Just new names for the same thing. Okay. So is this graph even or odd or neither? Does it have y-axis? Not quite, huh? Almost, but it's not quite the same to the right as it is to the left of the y-axis. So it doesn't have y-axis. It's not even. Is it odd? No. It's neither. It's neither even nor odd. Question, Rachel?
Yeah, can you go back for a sec? I didn't catch all of it.
Oh, yeah. Yeah, so write that down if you didn't get that. So y-axis is even, origin symmetry is odd on that. So this one is neither even nor odd. All right, so how about number 7? Even or odd? Neither again, right? That's not the same right and left of the y-axis. It's not the same through the origin. It doesn't even hit the origin. So neither one. Hey, what's his, one thing I might want to show you, what's his range? They will ask you that. Bottom, top?
6 to infinity.
I think the dot's at 6. It goes below the dot a little bit. Looks like 5, right?
Oh.
So I think this is 5 to infinity. Yeah, and parenthesis at the 5, huh? To infinity, it's right there. Yeah. Parenthesis, 5 to infinity. Everybody good with that? Because it doesn't. Can everybody see that graph? It comes down, but it doesn't quite touch the 5. Is it too small for you to see? See how this is 1, 2, 3, 4, 5. So this right here, this line is at 5. The dot is up at 6.
So it's not coming down?
So it's leveling out. It'll never go below. What's really there is an asymptote line. They're just not showing it. They're holding off on. We'll get into that in a couple weeks. So yeah, there's really a dotted guideline there, an asymptote line, and it's getting closer to that line forever, but it never touches it. It never reaches 5. That's why we don't have a bracket on the 5.
Okay.
That makes sense on that? So that's what they're showing you. Okay, is that one even, odd, or neither? That one's odd. odd. Because it has, right, if you flipped it upside down, it would look the same. Origin, symmetry. That one has origin, origin, symmetry. It's odd, right? Good. Even is y-axis, like x squared. Odd is origin. All right. Number 12 gives us a function and asks if it's even, odd, or neither. No picture. So now they're going to ask us if it's even, odd, or neither based on without a picture to look at. Now, you want to be careful. You want to have a right method. You could just look and go, well, look, odd powers. You kidding me? Easy question. Odd. Well, look at the next one. Odd power, but it's neither. So it's not that simple. I promise, if it was that simple, I wouldn't waste your time. I don't got time to waste. I would say, hey, if it's odd, just odd. Boom, done. But that's not true. So it's a little trickier. You can have odd numbers, and I'll give you one in a minute that has some odd numbers, and it's actually an even function. It has some odd and even. It's actually even. Sometimes odd and even, it's neither. Sometimes it's, anyway, there's a lot to it. How do you figure it out? How do you take a function like that and figure out if it's odd or even without a picture to look at? How are you going to know? Well, I don't got time for a long song and dance to tell you, but I do want to show you a little bit of the truth of it. Basically, a function, let's talk about even first off. A function is even. Let's think through how you could derive something here. Sorry, I'm getting that off the screen there. There we go. So, a function is even, meaning y-axis symmetry, right? Y-axis symmetry is even. A function is even if what it does to the right, it also does to the left. I didn't draw that too perfectly, but you know what I mean, right? Okay, so what does that mean about a graph? And what does that mean about a function, like plugging in values to a function? That means, doesn't it mean this? However far to the right you go, if you go up, if you go left that same amount and go up, it's always the same height. If you go right x, the height you get here is the same in the height as if you go left. Right? Doesn't it mean that? If I'm on a graph and I go, if I'm on some graph over here, and I go right some amount and left some amount, if I go right some amount and left the same amount, and I go up and I better hit the graph at the same height, huh? That's what it means to be the same on the right and the left of the y-axis. When you go right and you go left, the same amount, the height, of course mine doesn't even look good, does it? But pretend with me I drew better there. The heights are supposed to be the same. Always. As long as you go the same amount right. And if I go just a little bit right and go up, and go a little bit left and go up, they should be the same height. If I go really far right and go up, wherever it hits, same amount left and go up, it should be the same height, shouldn't it? Always. That's what it means to have y-axis. How do you say that with an equation? That means x and negative x plugged in should be the same y. What is y? F of x. Right? That means plug in x or negative x, and f of that will be equal. Same height. That's how you would test it. Plug in x or negative x, and they better come out equal. If for every x, the same amount negative is the same height, that's got y-axis symmetry, doesn't it? Is that making sense? Okay, I'm going to write this all neat and clean in a minute. Just think with me. Right now is thinking time, and then I'll write a neat little package. Step 1, step 2, step 3, boom, boom, boom. There's your answer. So we'll get there. And in fact, it's already in the sideboard. If you want to, there's the test for even and oddness on the sideboard. If you want to write it down, I'll write it. That's all neat and cleaned up. Final answer. Think with me now about the test for oddness. Right? So how do you know if a function is odd? Well, whatever it does over here, it's got to do down there. That'd be an odd function, right? For oddness, what does that mean? However far right you go and go to get a height, if you go left that same amount, it's down the same. So it's down. Negative f of x. This is positive f of x. So in other words, plug in x and negative x. And what's the truth? F of x and f of negative x, it's negative here, right? This and that. Everybody with me on that? Or maybe I'm not saying that very clearly. This, here, I didn't do that very well. This should be negative f of negative x, right? You're plugging in negative x, so negative f of negative x. It should be the opposite. So however far right I go, if you get plus 3, then left same amount should be negative 3. Right? If you go right plus 3, go right a little bit and up, left down should be the same thing. It should just be negative that. Negative in the front. Whereas the other one was nothing in the front, exactly equal. So there's the test. Let me write it out clean. So the test for even odd. Step 1. Plug in negative x. Step 2. Simplify. You got to clean it up a little bit to see if it really is the same. Is it now the same as the original? Right? We plugged in negative x. So that's really saying f of negative x equals f of x. Right? Because I just plugged in, we're saying, is it the same? Is it equal? Then it's even. That's what even means. You go right, you go left, it's the same. That's even. Is it the opposite of the original? Opposite of the original. Meaning, when you plug in the negative x, do you just get negative 1 times the original? Then that is odd. Otherwise, it's neither. So there's the test. So you plug in negative x, simplify, and you see, does it come out same as the original? Are they equal? Well, that's even. Is it the opposite? Now, what I mean by opposite is negative 1 times the original. Right? It's the original, f of x. Is the plug-in negative 1 times the original? If so, that's odd. Because it's just down instead of up. Otherwise, it's neither. On that. Yeah?
Wait, isn't the negative x supposed to be negative y as well?
What's that?
The f of x is supposed to be negative as well, right?
This right here?
Yeah.
I put it in over there. Now, are you looking back here and saying, well, Mr. Trade, you put them both negative here. Right, you know what I did? I just divided both sides by negative 1. And so the negative went here. So it's the same thing. See how that's the same thing? Basically, if you say one thing is negative this guy, or if this guy's negative that guy, that's the same statement, huh? Yeah, so I just whipped it over. I just thought it'd be easier for people to see this way. But they're the same. You're right. Either way, it's the same statement. Good on that? I'm making sense? Let's do it now. So there it is. I hope you got that in your notes. Let's actually do it now. Where was our question? Our question was this one. So negative 3x to the fifth plus 8x to the third. How do you know if it's even, odd, or neither? So take it and plug in negative x, right? Step 1. Plug negative x. So let me do that. And what am I going to get? Oops, I forgot the fifth power here. So what will it eat? And then step 2, simplify. What does it become? Isn't that positive? Yeah. And that minus? Yeah. Good so far. So what did I do? I took that original function here. And step 1, I plugged in negative x. So I plugged in negative x, plugged in negative x. Step 2, I simplified. How did I simplify? Well, see how many negative signs we have here? 6 negative signs, right? 5 and one more, 6 negatives, positive, huh? See how I got positive? 6 negatives altogether. 5 from the parenthesis, 1 more here, 6 negatives is positive. And this is 3 negatives, so it's negative. Good? Okay, now the question is this now the same as that, the original?
No.
No. Is it the opposite?
Yeah.
Is it negative 1 times the original? Yeah. See how this has become positive and that's become negative? It's multiplying negative 1 through the original. It's changed all the signs. It's the opposite. So yes, it's odd. Makes sense on that? Just plug in negative x, simplify, ask, is it the same as the original? Is it the opposite of the original? Opposite means all the signs opposite, right? well, it technically means -1 times the original, right? Which in a minute we'll see is a little tricky.
So step 1 is plug in -x.
Yep, so go through the steps. So step 1, plug in -x. So give that a try. See if you can do that. All right, we good here, this working out. So plug in -x. And then simplify. So step 1, that. Step 2, simplify. So that's going to be what? Positive, because there's 4 negative signs there. And that. So then is that the same as the original?
No.
Here's the original. No, it's part the same, part opposite, huh? The original had 2 negatives. We have 1 positive, 1 negative.
But part is
So it's not the same. It's not the opposite. It's half same, half opposite. So it's neither. Make sense on that, Rebecca?
So if we have a number all by itself that there's an x acting on it,
Right.
it's going to be neither. Does that make sense?
N-
So, like,
right.
doesn't change.
But that's not true. Because say you had, what if they gave you just a number, nothing else, y equals 9. F of x equals 9. Then you'd plug in -x, nowhere to plug in, that's the same as the original. So that would be even.
Okay.
But yeah, if they have some x stuff and a number. Well, no, that's not true either. If they have some, yeah, so I would give you a shorter rule, Rebecca, I promise, if there was one. If they give you, see, here's the problem. You say, well, how about x of a number? Well, if that number's divided, instead of added, subtracted. Yeah, so, yeah, if you have numbers added and x stuff, that's going to be neither. Yeah, so you could say that. But you just got to be careful about trying to shortcut the rules. I would give it to you if they're... So number 14. So f of x. Okay, this one's got a trick. F of x is... Yeah, I'm gonna run out of time here, so let me just show you quick here. 7 through to 4 times -x. Good so far. Step 1, right, is plug in -x. Step 2 is simplify. Now, how do you simplify that? That's the 7th root of -4x. Good so far?
Is that 41 minus x?
That's a parenthesis there.
Oh, okay.
Yeah, so I'm plugging in -x. So plug in -x. So we get -4x. Now, the question is, how does that compare to the original? Certainly not the same. The original didn't have any negatives.
Now it's imaginary.
Is it the opposite? What would be the opposite? It's not the same, but is it? What would the opposite be? The official test I gave you, let's go back to it, said opposite right here, says, is it -1 times the f, the original, right?
Yeah.
Is it?
Yes.
Is this, where are we? Is it -1 times, what's the original?
Yeah.
7 through to 4x. Is this that?
Yes.
It is. Is negative inside the same as negative outside?
No, that's different.
That's different, yeah.
That's different.
Right? You everybody see the question first off? Step 1, we plugged in, not out, in a negative. Right?
Yeah.
And we're saying, is that the opposite? Meaning, is that -1 out times the original? Is that?
No.
And the answer is yes. But do you know that? Maybe not. It looks like not. So you need to know that fact from algebra. That is the fact that odd powers, you can take the negatives out. Even powers are imaginary. Only evens are imaginary, not odds. Are you aware of that? Think with me. What is the square root of, like, -9? Imaginary, right?
Yeah.
Okay.
That's imaginary. You can't do that. What times itself is -9? Nothing. -3 times -3 would not be -9. It'd be positive. Right? Now, that is the square root. I think we say that word without realizing what we're saying. That is the square root. Square. Why are we saying square? Where's the square? Why are we saying
I
that?
don't write it because you don't.
Even
it's
number.
like
What does square mean? What does square mean?
Times itself.
2.
Yeah.
Specifically 2. What's this called? X cubed?
No, x squared.
X squared. So when we say square, we mean 2. What's the word for 3 in math?
Cube.
Cube. So let's be crystal clear on that. When we say square, we mean 2. When we say cube, we mean 3. So when I call this a square root, I mean there's a 2 there.
Yeah.
And that matters, because you're saying what twice is -9? Nothing. Okay, but what if we did the cube root of, like, -8? Could we do that? What times itself 3 times would be -8? Yeah, quite doable. -2.
Yeah.
times negative 2 times negative 2 would indeed be negative 8. See, there's no problem with negatives in an odd root. It's only in an even. Did you know that from algebra? This is why I say we're becoming a master of algebra. You've had it, but now you need to really know it well. So odd roots, negatives are okay. Even roots, they're not. So even roots, negative inside, or no negative inside. Odd roots, it's okay. And you can just pull them to the front, right? The answer just comes to the front. So this is a 7, it's an odd. So you can pull it out, it's okay, it's a yes, thus it's an odd function. It is the opposite. It is negative 1 in the front of the original. So negative inside is the same as negative 1 in the front, opposite of the original.
And it doesn't matter what odd number is on the outside, right?
Doesn't matter what the odd power is. 7, 9, 11, 13, 15. Possibly can. I don't know where the time goes. But here's what we got to do. We want to put into our graphing calculator. There's the y function up there. y1 equals x cubed minus 5x plus 3. And there, so put that into y1 in your graphing calculator. And they're telling me the window. We're going to do something new today in 3 minutes here. And they're telling me the x min. It's nice. They're giving me the window. X max. This here is y min, y max. So put in your window. Open your window button. Put in x min, negative 2.
Not minus 2, negative 2.
Yeah, negative 2, x max, positive 2, y min, negative 4, y max, positive 10. And then put y1 into your graphing calculator there. And so it's the function at the top. It's the f of x at the top. So type that into y1. Hit the y button on your graphing calculator, the upper left-hand corner. And put that in. And then make sure your window's right and hit graph. And you should get this picture. Everybody good there?
No.
Then I want to show you how to do min and max real quick.
You want us to put the minimum and maximum? Sorry.
We'll get there. So everybody got that graph. I want to make sure we all got that graph. So just type in y1.
X to the third minus 5x plus 3. Okay.
Put that into y1. And make your window set correctly. You should get that correct. So hit the window button. Hit the window button. And then the x min, x max, y min, y max stuff.
Y minimax minus 4, y maximum is 10. Or say what?
Minus 2 plus 2. Minus 4 plus 10.
Oh.
We good?
Okay. Hold on. 2.
And how do we know to put those x?
They're telling you x is between negative 2 and positive 2. Y is between negative 4 and 10. We good? Got that into y1 for our function? Hit the graph. It should look like that. There's the answer. And then I want to show you the max min stuff. So now, how do you do? What they want is they want you to find the maximum and the minimum. They want you to find this point right here. This is the max. How do we find that in our calculator? Let me write the steps. So what we do is we hit to find a max. You hit, in fact, I'm going to go to a fresh screen. Y'all got that? Well, maybe I better. No, I need a screen. So to find a max, step 1, we'll graph it. Step 1 is graph it. So you've got the graph now on the screen. Step 2, hit second, trace calc, that button. And then go down to where you see max and hit enter. So hit the second calc trace. And then you'll see a menu open up. Go down that menu to maximum and hit enter. All right, then you'll get 3 questions. It's going to say left bound, right bound, and guess.
No.
Right now, yeah, first one at a time. So first comes the left bound question. So it'll say left bound. What it's wanting you to do is move the dot somewhere to the left of the max. Here's the max. You move the dot to the left
Move it right.
and hit enter.
Press enter.
So you move
Press yes.
move left and hit enter. And then for the right bound, you move somewhere over here to the right. This is the right. This is the left. Move right, and hit enter. And then for the guess, just hit enter. You'll come up with an answer, which is, I don't know.
I wanted to throw this thing out the window, but I remembered that.
So you guys getting that on your screen? Let me give you the answer real quick. So this max is negative 1.29 for x, 7.30 for y.
Yeah.
Y'all getting that? Does that make sense? So you got to move your cursor left. What you're doing when you do that is you're giving the calculator a zone to search for the max. That's what you're doing. That's why it wants left bound, right bound. You're basically saying, hey, calculator, search in this zone for the maximum. Here's the left edge, right edge. Search in that zone for the maximum. You just move left, hit enter, move right, hit enter, and then just hit enter for guess, and it'll find it, those values. All right, we're out of time.